So this question is coming from May June 19, paper 3, variant 2, and this is the seventh question of the paper. We are given a differential equation, and in the first part, we are supposed to solve this equation and get the answer of y in terms of x. We are given these conditions to find the value of integration constant. And by the way, these kind of equations are not given to you in the examination. I have just written over here for the purpose of practice. Let's say after solving the differential equation, you get y is equal to something which is not in the format. It will help you understand that, okay, yeah, I can still simplify it further. Right? Of course, you can also look into the marking scheme and see what is the final answer that you need to get. But yeah, as I mentioned even in my previous videos, during the practice, always try to simplify as much as possible, even if it's not mentioned in the question. And that is an ideal practice, to be honest. Being a mathematician, you need to simplify as much as possible. So yeah, let's get started. The first things first, from this derivative term, I'll shift the denominator to the other side. So it means that my y term will be on the left side, x term will be on the right side. And over here, how will you divide this term such that x stays on the right and the y term stays on the left? Of course, you can write e to the power of x plus y as e power of x, e power of y. So let us go ahead and try to write this equation first of all. D by dx is equal to x times e power of x times e power of y. Now let me take the y terms to the left side so that it will become 1 over e to the power of y dy is equal to x e to the power of x dx. Now I can integrate on both the sides. So of course I'll just do the integration a bit separately. I'll say that integration of x e to the power of x dx can be done with the help of integration by parts. I'll say that u is equal to x, v is equals to e to the power of x. I'm using the Eilert rule over here. So my u dash will be equal to 1 and integration of v will be equal to e to the power of x. Now the formula that I'm going to use is that integration of uv will be equal to u integration of v minus integration of u dash integration of v. Of course, you have learned another formula. You can go with another formula, but this is the formula that I am good with. So I'm going to use it over here. So u into integration of v will become x into e to the power of x, then minus integration of u dash into integration of v, which is e to the power of x dx, which if I simplify, it will simply become x e to the power of x minus e power of x. And of course, plus c because this is the right hand side of the integral. And you know, if you watched my previous videos, I like to have my integral constant on the right hand side. And now I can simply go ahead and integrate the left side, use this integration output on the right side, and then find the value of c. So the left side is simply e to the power of minus y dy. So how do you integrate this? It is e power of minus y divided by minus 1. So I can say that, therefore, minus e to the power of minus y is equal to the entire thing on the right hand side, x e to the power of x, or I can take maybe e to the power of x as constant. I mean, sorry, what do you call it? Common, and then x minus 1 plus c. Now I can substitute y is equal to 0, x equal to 0 to find c. Substitute x equal to 0, y equal to 0, and then in that case, let's see what do we get for c. So anything to the power of 0 is 1, so this is minus 1. This will be minus 1. So this e to the power of 0 is also 1, right? So 1 into minus 1 is minus 1. So this minus 1 will go to the left side and will become plus 1. So your c is equal to 0. And this will simply say that you are having your minus e to the power of y or minus y is equal to e to the power of x, x minus 1. Now what is the format that we wanted? We want to express y in terms of x, and it should be looking something like this. Let me first shift this negative sign over here so that it becomes 1 minus x. So e to the power of minus y is equal to e to the power of x, 1 minus x. The reason behind this is because I wanted 1 minus x, not x minus 1. So I've just shifted this to the other side so that I can get this particular format. Now I can bring ln on both the sides. So that is going to become ln of e to the power of minus y is equal to ln of e to the power of x. Then of course ln of a times b is equal to ln of a plus ln of b. So I can write this as ln of 1 minus x. This is e to the power of x and then plus ln 1 minus x. Okay, or else it will just be ln of ex e to the power of x 1 minus x, and then I'm just getting to this particular step. Now from here, what I can do is I can bring this minus y down. Ln e is 1, so minus y is equal to, this is x plus ln of 1 minus x. We wanted, alright, the same thing. Just shift minus sign on the right hand side, and therefore you will have y is equals to minus ln of 1 minus x minus x. So we are satisfied with the output that we wanted, and this becomes your final answer. The next part is asking us, explain why x can take values that are less than 1. Explain why x can only take the values that are less than 1. So let us try to understand this. Ln of inputs only exists for greater than equal to 0 values. I mean, sorry, greater than 0 values. Even at equal to 0, it does not exist. So I know that 1 minus x has to be greater than 0 for ln 1 minus x to exist. When I say to exist, basically it gives you the output. For example, if I take my calci and write ln of minus 1, let's say, it does not exist. What about ln of 0? It does not exist. Only the values that are greater than 0, it could be 0.5, it could be any kind of value that is greater than 0, let's say 100. So all these kind of values exist. If you have looked at the graph of ln, it looks like this. There is no input for the negative values or 0. If you go closer and closer to 0, the outputs will become closer to negative infinity. You can try it. If I'm having ln of 0.00001, let's see what do we get. You can see that it's currently minus 13. And if I keep on increasing zeros, you can see that I'm getting more and more negative values. So yeah, over here we need to understand that 1 minus x has to be greater than 0 for this to give you a valid output. And therefore, if you shift your x to the other side, it will become x is less than 1. And that is what the question was asking. Explain why x can only take the values that are less than 1. So that is the final conclusion. You can write a statement for x less than 1, ln of 1 minus x will always exist. Will always exist. So yeah, that is how you can conclude your final answer.